Hello, we are Group 21, and our project topic is sixth generation technology for wireless communication. My name is Yao Hui, and my partner is Wang Xunlei. The presentation will be provided by both of us. So let's start from the introduction, and first we introduce the background of technology of wireless communication. So from 1G to 6G, every new generation is introduced in almost a time span of 10 years. In 1980s, the 1G, which is for the voice calling, and 2G is for the data service. And in 2000, the third generation of technology is for the video calling, and the 4G is for HD video, like streaming. And nowadays, uh, we usually use 5G, which is come out in 2020. The 4G is actually have a much greater performance than the 5G have a much greater performance than the 4G, and we usually use the 5G in the smart city. And however, nowadays this AI become one of the hottest topics all over the world. So there are many applications regarding the artificial intelligence. For example, AR, which is reality, and VR is visual reality, and XR, and also with the um, IoE, which is Internet of Everything, and as well as the Edge AI. So for this application, we urgently need a better technology to support the construction of an intelligent world than 5G. So this is why we need 6G technology. And now we introduce some demands to 6G. So the figure in the right side is about the demands of 5G and 6G, while the demands to 5G is on the top, and at the and to the down we show the demands to 6G. Now we merely introduce some of the demands of 6G. So the first is the increasing demand for bandwidth in some normal application. Since in our class we know the bandwidth is very important for the wireless communication. A wider bandwidth can support a much higher quality communication. So as we mentioned about the AR and as well as the AI-driven automation, uh, uh, they they have a very strict requirement in the real times performance. So one of the demands of 6G is we need a much wider bandwidth than 5G. And the second point is the ultra low latency. Um, Although in 5G is latency is very low, but in some novel AI application, we still need a much higher or ultra low latency in this remove operation. And the third point is the expanding coverage to provide global coverage. For example, the Starlink from SpaceX, they are use a lot of satellites to uh, achieve global coverage communication. And the last point and last point is and the next point is is the increasing security concern. Now in 6G, we will integrate 6G with the cultural communication, because cultural communication can greatly adjust the security concern, the problem. And the last point is the sustainability and energy efficiency. Because in the 6G, we need massive uh, MIMO antennas, which means it may cause large energy consumption. So uh, one of the problem is how to trade off, how to achieve the trade-off between the performance improvement and energy efficiency.
Hello, my name is Wang Xunlei, and let me introduce the core technologies of the 6G. First part is the key features and advancements. And in the key features and advancement, let me introduce the let me introduce the terahertz communication, faster data transmission. In the 6G communications, a critical challenge is spectrum crunch. One key solutions to slow the existing spectrum crunch is to utilize the T-Hertz band. You can see that in the figure 3, it's a T-Hertz spectrum. It operates in the regions of 100 gigahertz to 10 terahertz, which is expected to assist the infrared and millimeters wave band. T-Hertz communications is characterized by high securities, moderate energy consumption, short range, and robust to atmospheric conditions. T-Hertz also has some challenges such as high penetration loss, molecular absorption, significant propagation loss, limitation in RF circuits, and so on. Maybe these challenges can be slowed by selecting frequency bands which are less affected by the molecular absorptions. On the other hand, T-Hertz band can facilitate with ultra-fast massive data transfer to support many applications. Therefore, it is investigated to be among key enabling technologies for future 6Gs. The second part is AI-driven network, autonomous and self-optimizing systems. Artificial intelligence and machine learning technologies are expected to be the core technologies in the future 6G wireless communication systems, and it can also be used to enhance the communication system performance and process massive amounts of data, reduce energy assumptions and end-to-end network latencies. However, artificial intelligence and machine learning also has various challenges in wireless communications, including classifications, network optimization, signal detections, and so on. So consequently, the integration of 6G with AI is one of the promising topics in academic as well as the industry. The second part is quantum communications and the securities. With the continuous development of communication network, securities has become an important issue. In addition, the traditional technical problem, such as virus and the DDoS attacks, usually will face a set of new security threats. And the quantum communications, which allows strong communication system securities for 6G wireless networks, is a new promising technologies for future 6G network. This is achieved by applying a quantum key technology, which is accomplished based on the principles of uncertainties and the quantum no-cloning theory. Quantum communication technology has the potential to enhance the detection efficiencies of unauthored eavesdropping activities. So therefore, quantum communications can be useful for the future 6G communication networks. The fourth part is a massive MIMO and smart antennas. You can see in the figure 5 is a cell-free massive MIMO with a large number of distributed access points. As one of the key technologies for 5Gs, the initial idea of massive MIMO was first proposed by Mazata from Bell Labs in 2009. In 6G systems, large antennas arrays comprising hundreds or even thousands of antennas, known as ultramassive MIMO, will be utilized. Ultramassive MIMO has an exciting application prospect because of its unique characteristics. First, further expansions of the antenna scale can provide spatial beams with very high spatial resolutions and processing gain, thus improving the multiplexing capabilities and interference suppressions of the networks. So in summaries, there are important issues and trends in ultra-massive MIMO, which are listed as follows, as how to reduce near-field and wideband effects, how to utilize high-frequency bands, etc. And the next part of the core technologies is the network architecture and infrastructures. First, let me introduce the cloud and the edge computation integrations. The mobile edge computation (MEC) is considered as important type of edge computing platform that locates on the edge of the cellular. And the key concept of MEC is to move part of the service-specific processing, computing, and data storage from the centralized core network to the edge network core nodes, which can be located near data providers and end users. Also, MEC is considered as a key enabling technologies to achieve traffic optimizations, and it can enhance the performance of 6G network. Because using MECs in the 6G network can significantly enhance the network capacities, facilitate crucial delay-sensitive tasks, and effectively handle network-intensive computations. All these essential tasks with MEC can be accomplished based on the virtual software-based platform or use the SDN. The second part is a satellite-based and non-terrestrial network (NTN). You can see in the figure 7 is the integrations of terrestrial and non-terrestrial network to achieve full coverage. Satellite communication is using to achieve broadband connectivity, high capacities airborne platforms, and accurate global coverage. And the main aim of the 6G networks is to integrate satellite platform with the terrestrial network. Therefore, the satellite-based and the non-terrestrial networks were introduced. Typically, the satellite stations are divided into 3 platforms based on their orbit characteristics. You can see that it is the GEO, MEO, and LEO in the figure 7. Also, satellite communication may face some technical challenges such as Doppler variance and Doppler shift. So how to utilize the NTN and the satellite-based communications of 6Gs needs to be further discussed. And the third part is a new way from modulations, coding, and random access. First, let me introduce a new waveform. 6G has more diverse and complex applications scenarios. This improvement poses new challenges to waveform design and modulation. During the development of the 5G standards, multi-carrier systems such as OFDM have primarily been used due to their high spectral efficiencies. However, this system exhibit a high peak-to-average power ratio. So, to better accommodate diverse application scenarios and simplicity in 6G systems, novel waveform designs are expected to deliver enhanced performance to specific requirements. For high mobility scenarios, waveform in transform domain, such as orthogonal time frequency space (OTFS), can describe information such as delays and Doppler more accurately. And the second part is modulations. Modulation technicals significantly influence the efficiency and the reliabilities of communication system. Currently, the QAM is widely used and has been adopted by both long-term evolutions and new ratio standards. But some other modulation technicals has also attracted attention due to their advantage in fitting in peak-to-average power ratios and robustness, including selective QAM, irregular QAM, and index modulations. The last part in my part is coding and random access. Efficient channel coding technologies can improve the capability, reliabilities, and qualities of the service in the communication system. You can see that guided by the Shannon series, error correcting code realized a leap from the algebraic coding to probabilities decoding, which had great success in improving the capabilities, reliabilities, and quantities of service in communication systems. Among them, the most popular ECCs are trump codes, low densities, parity checked codes, and the polar codes. These codes are the standard codes for these codes are for the 4G data channels, 5G data channels, and 5G control channels respectively. Driven by the ultra-low latency and high reliability requirement of 6G communication systems, ECCs are expected to utilize the shorter code lengths. However, shorter code lengths weaken the effectiveness of the randomness and channel polarizations and reduce the decoding performance of their decoding methods. One alternative approach is to employ near maximum likelihood decoding schemes designed for class for the traditional algebraic codes, which are also applicable to any linear flow codes, such as the OSD and the recent proposed capabilities, achieving Gaussian random additive noise decodings. LTE employs OFDM, and the 5G NRUs optimize the OFDM-based waveform and multiple access, both of which are orthogonal multiple access technologies. NOMA is recognized as the most promising modern random access technologies for 6Gs. It's meeting the needs of the low-cost, high reliabilities, low latencies, and massive connectivities. In contrast to traditional OMA technologies, the core idea of the NOMA is to encourage multiple terminals to ensure the same ratio resource in the time frequencies So the OMA is expected to improve the spectrum efficiency, increasing system capacities, reduce system latencies, and so on. In summaries, there are some challenges have to be addressed before the practical applications of OMAs, like the high performance, low complex activities, multi-user interference, and so on. Moreover, a common and unified 60-day normal framework needs to be developed in the futures to solve the problems of the NOMAs. And the next part is potential user scenarios. You can see that in the figure 8, we show some application support by the 6Gs. It contains the 4 parts of the potential use scenarios.
So let me introduce the society and economic impact of 6G. So we can see in figures, in the figure in the right side, there are some Internet of Smart Things example with the 6G application. So here we introduce some of them. First is the
我知道，就是刚刚问你，电网那已经推了20%不到。
可以啊，就几分钟讲完先嘛。So let me introduce the society and economic impact. As for the economic impact of 6G, we can see that in the figure in the right side is some example of Internet of Smart Things. So by integrated 6G technology, IoT become smarter, and then so the first is the smart city. Smart city actually is come from 5G, but in 6G it still has a promising application. So smart city means it use a massive amount of sensors which can improve the quality of service offered by the citizens and make our public and have a better assignment of the public resource and reduce the operational costs. For example, we may deploy some sensors to monitor air quality, which may help in reducing greenhouse gas emission. So the other is monitor the traffic congestion and the traffic management. This is and the last point is the last example is monitor some energy consumption in the electricity grid. So the second point is the second example is the smart grid. Smart grid is can be integrated by 6G to improve the electricity production and transmits the traditional energy gram into a distributed generation system, which can smartly control the energy usage. Since it is a distributed system, so in this system, some wireless communication is quite important. So 6G technology is can greatly empower this system. So the last example is smart factory. In this, it is the part of the smart industry, and so the 6G we will use 6G in here to keep a reasonable balance between the supply and demand and make advanced product planning and developing, then to achieve best practice selling and shipping products. So now we move to the society impact. So the first point is utilizing 6G technology, the social resource may be allocated more fairly. For example, uh, in the education resource allocation, although 5G can offer great experience of removed class, 6G can further make the class more active through the XR and AR. For example, we may see that some students from developing region, they can enjoy the class provided by some very famous lecturer as if they are in the lecture room. So it can be achieved by using the AR or XR. And 6G is a very important basic of them. Then the second part is 6G can provide a policy and security of our data, attack it efficiently. Because in 6G, we can combine with the cultural communication. Since the cultural communication is the most important feature of it is security. So if the 6G with cultural communication will greatly protect our data. And the last point is the environment consideration. As we mentioned in the introduction, the price of 6G 6G will use massive MIMO antenna to improve the performance. So the great performance of 6G is the price is the high energy consumption. However, the global world is promoting the goal of carbon neutrality, and it's necessary for us to control the energy cost of 6G. However, a physical approach is AI-driven 6G system, where the power consumption can be optimized by using AI, thereby the mechanism to control energy costs will become dynamic instead of stick in the past generation wireless communication. So the takeaway is we introduced the 6G technology and also highlighting its social and economic impact and its technical method. So there are some key features and advertisement where has been introduced, like text communication, AI-driven network, cultural communication, and ultra-massive MIMO antenna system, and innovative network architecture like MEC. And also we introduced some network architecture and infrastructure, like, for example, the non-orthogonal multiple access, which is NOMA. And we also introduced some potential application scenario of 6G. So in the future of 6G, the biggest challenge is the hardware design, and which is how to design the hardware to achieve such a high performance. And the other point is the consideration of energy consumption, because we need to trade off the energy consumption and the high and the great performance. And this is all for our presentation, and thank you.